Dear students, we already completed polynomials part 1. So prepare notes thoroughly, prepare very well. Now we are going with polynomials part 2. Example 2. What is the question? Find the zeros of the quadratic polynomial p of x equal to x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. What we have to find? We have to find zeros of the given quadratic polynomial. How to find the zeros? They gave quadratic polynomial. By splitting the middle term, we will find zeros of the quadratic polynomial. Here, step 1, write the polynomial. Given polynomial p of x equal to x square plus 7x plus 10. To find the zeros, we write p of x equal to 0. Always to find the zeros, we have to take p of x equal to 0. To find the zeros, we write p of x equal to 0. So take p of x is x square plus 7x plus 10. In place of p of x square plus 7x plus 10 taken. So x square plus 7x plus 10 equal to 0. Identify coefficients. Now what is the standard form of quadratic polynomial? Ax square plus bx plus c. This is the standard form of quadratic polynomial. What is the standard form of quadratic polynomial? Can you say? Ax square plus bx plus c. What is the coefficient of x square? A. What is the coefficient of x? B. What is constant? C. So we are comparing given polynomial with ax square plus bx plus c. So what is A? A is x square coefficient. Here x square coefficient is 1. So A equal to 1. What is B? X coefficient. Here x coefficient is 7. So take B equal to 7. What is constant? Constant is 10. So take C equal to 10. Find the product A and C. A is 1, C is 10. AC is equal to 10. 1 into 10 equal to 10. Now to find two numbers whose product is 10 and whose sum is 7. Now I have to find two numbers. Those two numbers product should be 10 and those two numbers sum should be equal to 7. So factor pairs here, factor pairs of 10, 1 into 10 equal to 10, 2 into 5, 2 into 5 equal to 10. So product of these two numbers giving 10, if we add 2 and 5, here adding, if we add 2 and 5, we are getting 7. So required numbers are 5 and 2. So these two numbers are giving 1 into 10 equal to 10. This is A, this is C, this is x square coefficient. 1 is x square coefficient. This 10 is constant. So x square coefficient into constant giving 10. So if we have to choose two numbers whose product should be 10, and if we add those two numbers a sum, that should be 7. 7 is middle term coefficient, x coefficient. 7 is coefficient of x. So required numbers are 5 and 2. Now splitting the middle term. What is this step? Splitting the middle term. Middle term, what is middle term? 7x is the middle term. How we are splitting it? This is equal to x square. 7x only we are splitting. X square written as it is. 7x, how I am writing? I got two numbers 5 and 2, right? So 5x plus 2x giving 7x. 5 into 2 giving 10. 5 into 2 giving 10 and 5 plus 2 giving 7. That's why, so x square plus 5x plus 2x plus 10. Step 6, factorization. Already middle term split it. So x square plus 5x plus 2x plus 10. Now taking x common, x times x plus 5 plus 2 times x plus 5. So taking x plus 5 common here, so equal to x plus 5 times x plus 2. Finding the zeros, x plus 5 into x plus 2 equal to 0. To find the zeros, we have to equate it to 0. So p of x equal to x plus 5 into x plus 2, this is equal to 0. So x plus 5 equal to 0 or x plus 2 equal to 0. So x equal to minus 5, x equal to minus 2. From this I got x equal to minus 5. From this I got x equal to minus 2. Therefore the zeros are alpha equal to minus 5, beta equal to minus 2. Relationship formula, relationship between zeros and coefficients. For a quadratic polynomial ax square plus bx plus c, if zeros are alpha comma beta, then alpha plus beta equal to minus b by a, alpha beta equal to c by a. This is the formula. Alpha plus beta is equal to minus b by a. This is the formula, and the product alpha beta equal to c by a. This is also formula. This is a relationship between zeros and coefficients. Alpha and beta are zeros. A, B, C. A, B, C are coefficients. Here in the standard polynomial, those are the coefficients. C, x square coefficient A, x coefficient B, constant C. Now verification. Verify the relationship zeros. Alpha equal to minus 5, beta equal to minus 2. Already we got these zeros. Sum of zeros we are finding now. So alpha plus beta, minus 5 plus minus 2. Minus 5 plus minus 2 giving minus 7. Minus 5 plus minus 2. So minus 5 minus 2 giving minus 7. Now finding minus b by a. Minus b by a. So what is b? B is 7. So minus 7 by 1. A is 1. So minus 7 by 1, that is minus 7. So alpha plus beta, you got minus 7. Minus b by a also we got minus 7. So alpha plus beta equal to minus b by a. So we verified it. Now product verification. In this step, product verification. Product of zeros. So alpha into beta is equal to, so alpha is minus 5, beta is minus 2. So minus 5 times minus 2 giving 10. So c by a we are doing now. C is 10, a is 1. So c by a is 10 by 1 equal to 10. So alpha beta equal to c by a. We verified. Now example 3. Find the zeros of the polynomial p of x equal to x square minus 3 and verify the relationship between the zeros and the coefficients. So recall the identity. A square minus b square is equal to a minus b times a plus b. This is the identity. Using this identity, we can write x square minus 3 is equal to x square minus root 3 whole square. X square minus root 3 whole square. So a square minus b square. What is the formula? A square minus b square is equal to a minus b times a plus b. So x minus root 3 times x plus root 3. X minus root 3 times x plus root 3 equal to 0. To find zeros of the polynomial, we are equating p of x to 0. Here p of x is x square minus 3. X square minus 3 we have written as x minus root 3 times x plus root 3. So we are equating it to 0. what we are getting? X minus root 3 equal to 0 or x plus root 3, x plus root 3 equal to 0. X minus root 3 equal to 0 or x plus root 3 equal to 0. So x equal to root 3 or x equal to minus root 3. Hence the zeros are alpha equal to root 3, beta equal to minus root 3. Verification, given polynomial x square minus 3, so a equal to 1, b equal to 0, c equal to minus 3. What is a here? X square coefficient. What is b here? X coefficient. In the given polynomial, there is no x term. So we can write this polynomial as x square plus 0, 0 times x minus 3. So a equal to 1, b equal to 0. 0 is x term coefficient. X coefficient is 0. What is constant? Constant is minus 3. Sum of zeros, already we found the zeros. Alpha plus beta is equal to, alpha is root 3, beta is, we got minus root 3. So if we add these two, we are getting root 3 minus root 3 equal to 0. Sum of zeros you are getting 0. Verification, given polynomial x square minus 3. So a equal to 1, b equal to 0, c equal to minus 3. Sum of zeros. So already we verified it. Alpha plus 3, beta is equal to root 3 plus or minus root 3 equal to 0. So minus b by a. Minus b by a is equal to b 0 by a is 1. So minus 0 by 1 gives 0. So alpha plus beta I got 0. Minus b by a also I got 0. What it implies? Alpha plus beta equal to minus b by a. We have verified it. So product of zeros, alpha beta is equal to root 3 times minus root 3. It is giving minus 3. C by a. C value is 3. So minus 3 by a value is 1. Minus 3 by 1. It is giving minus 3. So alpha beta equal to c by a. Minus 3 equal to minus 3 we got. So we have verified the product of zeros is equal to c by a. Alpha beta is equal to c by a. Alpha plus beta is minus b by a. Alpha beta is equal to c by a. Now example 4. Find a quadratic polynomial whose sum of zeros minus 3, product of zeros 2. We have to find quadratic polynomial. Sum of zeros is already given. Sum of zeros means alpha plus beta. Alpha plus beta is given. Product of zeros means alpha beta is given. For a quadratic polynomial p of x equal to ax square plus bx plus c, sum of zeros alpha plus beta equal to minus b by a, alpha beta equal to c by a. If alpha and beta are the zeros, alpha plus beta is minus b by a, alpha beta is equal to c by a. Now substituting the values, alpha plus beta equal to, they gave in the question, sum of zeros is given minus 3. Product of zeros is given 2. So alpha plus beta equal to minus b by a. So in place of alpha plus beta, you can write minus 3. So minus 3 equal to minus b by a. So b by a equal to 3. So b equal to 3a. Alpha beta equal to c by a. Alpha beta is given 2. Alpha beta is 2. So c by a equating to c by a. So c equal to 2a. Cross multiplication, c equal to 2a we are getting. Substitute b equal to 3a, c equal to 2a. In ax square plus bx plus c. So we are getting ax square. In place of b, we are taking 3a. In place of c, we got 2a. So take 2a. So ax square plus 3ax plus 2a. Ax square plus 3ax plus 2a. Taking a equal to 1, we are getting the polynomial p of x equal to x square plus 3x plus 2. We have taken a equal to 1. So 1 into x square, 3 into 1 into x, 3x, 2 into 1, 2. Therefore, the required polynomial is x square plus 3x plus 2. This is required polynomial, x square plus 3x plus 2. Example 5, verify that minus 3, minus 1, minus 1 by 3 are zeros of the cubic polynomial. They gave the cubic polynomial and they gave the zeros of the cubic polynomial. We need to verify whether this 3 is 0 of p of x or not. Minus 1 is 0 of p of x or not. Minus 1 by 3 is 0 of p of x or not. That we have to verify first. And verify the relationship between zeros and the coefficients. So given cubic polynomial is 3x cube minus 5x square minus 11x minus 3. That is given cubic polynomial in x. Now in place of x we are taking 3. Now we are verifying that whether 3 is a 0 or not. So in place of x taken 3. So p of 3 equal to 3 times 3 cube minus 5 times 3 square minus 11 times 3 minus 3. So equal to 3 cube means 27. 3 3 is 9, 9 3 is 27. So 3 cube is 27. 27 into 3 giving 81. So 3 square is 9. 11 3 is 33 minus 3. So 3 times 27 81. 5 times 9 45 minus 33 minus 3 equal to 0. So we verified that 3 is a 0 of the given polynomial. Now verifying that minus 1 is a 0 of the given cubic polynomial or not. So in place of x we are going to take minus 1. P of minus 1 is equal to 3 times minus 1, 3 times minus 1 whole cube minus 5 times minus 1 whole square minus 11 times minus 1 minus 3 equal to minus 1 whole cube is minus 1. So 3 into minus 1 minus 3. Minus 1 whole square is 1. So minus 5 times 1 is minus 5. Here minus 11 times minus 1. We are getting plus 11 minus 3. So equal to minus 3 minus 5 minus 8 minus 8 minus 3 minus 11. So minus 11 plus 11 giving 0. So we got p of minus 1 equal to 0. If we get p of minus 1 equal to 0, what we can say about minus 1? Minus 1 is a 0 of p of x. Now we are going to verify that minus 1 by 3 is a 0 or not. So in place of x we are taking minus 1 by 3. So p of minus 1 by 3 is equal to 3 times minus 1 by 3 cube minus 5 times minus 1 by 3 whole square minus 11 times minus 1 by 3 minus 3 equal to 3 times minus 1 by 3 whole cube is giving minus 1 by 27 minus 5 times minus 1 by 3 whole square is giving 1 by 9. So minus 11 times minus 1 by 3 plus 11 by 3 minus 3. This is equal to 3 times minus 1 by 27. Here 327 we are cancelling. So 3 9s 27. So minus 1 by 9 minus 5 by 9. This is 11 by 3. Here minus 3. So after simplification, what we are getting? Minus 1 by 9 minus 5 by 9 is minus 6 by 9. So written minus 6 by 9 plus 11 by 3 minus 3 equal to, here 6 and 9 we are going to cancel using 3 table. 3 2 6, 3 3 is 9. So minus 2 by 3. I got minus 2 by 3, 11 by 3, minus 3. If you add these two, minus 2 by 3 and 11 by 3, what we are getting? 11 minus 2, 9. 9 by 3 gives 3. 9 by 3 gives 3. So 3 minus 3 equal to 0. So we got P of minus 1 by 3 equal to 0. So what we can conclude? Minus 1 by 3 is a 0 of P of x. For cubic polynomial ax cube plus bx square plus cx plus d, if zeros are alpha, beta, gamma, alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha equal to c by a, alpha beta gamma equal to minus d by a. Now we are going to verify that. Verification we are doing. So given polynomial 3x cube minus 5x square minus 11x minus 3. What are the coefficients now? We are writing the coefficients. X cube coefficient is a. We are taking a equal to 3, b equal to minus 5, x square coefficient is minus 5, x coefficient is minus 11. So c equal to minus 11, d constant minus 3. So sum of zeros, alpha plus beta plus gamma. Alpha is a 0, beta is a 0, gamma is a 0. So 3 plus minus 1 plus minus 1 by 3. These are zeros. After adding all these, we are getting 5 by 3. If you find minus b by a, minus of minus 5 by 3, we are getting 5 by 3. So alpha plus beta plus gamma, we are getting 5 by 3. Minus b by a, also we are getting 5 by 3. What it means? Alpha plus beta plus gamma is equal to minus b by a. So we have verified. Sum of zeros we have verified. Now sum of products of zeros. Sum of products of two zeros we are taking. First two zeros, alpha into beta plus beta into gamma plus gamma into alpha. So alpha beta, that is 3 into minus 1 plus beta gamma, that is minus 1 times minus 1 by 3 plus gamma alpha. So 3 times minus 1 by 3. After simplification, we are getting minus 3 plus 1 by 3 minus 1 equal to minus 11 by 3. So c by a equal to minus 11 by 3. C by a is equal to minus 11 by 3. We got alpha beta plus beta gamma, gamma alpha is minus 11 by 3. C by a also minus 11 by 3. What it means? We verified that alpha beta, beta gamma plus gamma alpha is equal to C by a. Now we are going to verify that product of zeros. Product of zeros is equal to minus d by a. So we are finding product of zeros. Alpha beta gamma, alpha into beta into gamma is equal to, we are getting 1, minus d by a, also we are getting 1. So alpha beta gamma is equal to minus d by a. We have verified it. Relationship between zeros and coefficients, general formula. P of x equal to a n x power n plus a n minus 1 x power n minus 1 plus and so on plus a naught. The zeros of the polynomial are the values of x for which P of x equal to 0. So degree for this polynomial ax plus b is a linear polynomial. What is the degree? 1. What is the relationship between zeros and the coefficients? Alpha equal to minus b by a. That is the relationship between zeros and coefficients. Now coming to quadratic polynomial ax square plus bx plus c. What is degree? 2. What is the relationship? Alpha plus beta equal to minus b by a. Alpha beta equal to c by a. Alpha beta equal to c by a. Now coming to cubic polynomial ax cube plus bx square plus cx plus d. This is cubic polynomial. Degree is 3. Now we are adding alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus gamma alpha is minus, here c by a. Alpha beta, beta gamma plus gamma alpha is c by a. Next coming to alpha beta gamma is minus d by a. First you are getting minus alpha plus beta plus gamma. You are getting minus b by a. Next alpha beta, beta gamma, gamma alpha. You are getting plus. So C by A. Next alpha, beta, gamma. Again you are getting minus. So minus D by A. Now coming to exercise 2.2. Question number 1. First one. Find the zeros of the quadratic polynomial p of x equal to x square minus 2x minus 8 and verify the relationship between zeros and the coefficients. Splitting the middle term. So p of x, x square minus 2x minus 8. To split the middle term, we have to take product of x square coefficient and constant. What is coefficient of x square? 1. What is constant? Minus 8. So 1 time minus 8 equal to minus 8. We need two numbers whose product is minus 8 and the sum is, we have to add these two. 1 plus minus 8. We are not getting minus 2. So we have to take two numbers whose product is minus 8 and whose sum we should get a middle term coefficient. We should get coefficient in the middle term. Coefficient of x we should get. So minus 4 into 2. If we take minus 4 and 2, minus 4 into 2 we are getting minus 8. If we add minus 4 and 2, if we add minus 4 and 2, minus 4 plus 2, we are getting minus 2. Minus 2 is x coefficient. Now factorizing it. Middle term minus 2x, we have written it as minus 4x plus 2x. So x square minus 2x written as minus 4x plus 2x minus 8 written as it is. Now grouping the terms. So take x common from first two terms. X times x minus 4 plus taking 2 common from these two terms. From last two terms we are taking 2 common. So 2 times x minus 4. So x minus 4 here, here also x minus 4. Taking x minus 4 common. So x minus 4 times x plus 2. Finding the zeros. To find the zeros we have to equate p of x to 0. So x minus 4 into x plus 2 equal to 0. So x minus 4 equal to 0 or x plus 2 equal to 0. So x equal to 4 or x equal to minus 2. Hence the zeros are alpha equal to 4, beta equal to minus 2. Verification of relationship. Given polynomial x square minus 2x minus 8. So a equal to 1, b equal to minus 2, c equal to minus 8. Sum of zeros alpha plus beta is equal to 4 plus minus 2. Alpha is 4 and beta is minus 2. So alpha plus beta we are getting 2. Now we are finding minus b by a. So minus of minus 2 by a is 1. So minus of minus 2 by 1. Minus of minus 2 by 1. Minus into minus plus. So 2 by 1. 2 by 1 is 2. Here we got alpha plus beta is 2. Minus b by a also 2. That means we have verified sum of zeros equal to minus b by a. Now product of zeros alpha beta equal to c by a. I have to verify this. So taking alpha beta value, alpha is 4, beta is minus 2. Alpha into beta giving 4 into minus 2, that equal to minus 8. So c by a I am finding minus 8 by 1. So minus 8 by 1 giving minus 8. So alpha beta I got minus 8, c by a also I got minus 8. So minus 8 equal to minus 8. That means alpha beta equal to c by a. So we verified the product of zeros. So we verified alpha plus beta equal to minus b by a and alpha beta equal to c by a. Now I want to show how we are splitting middle term. Here same quadratic polynomial I am taking. Same quadratic polynomial I am taking x square minus 2x minus 8. How I am splitting the middle term? Visual method. So a into c, x square coefficient is 1, constant is minus 8. So a into c equal to 1 into minus 8. You are getting minus 8. Find two numbers whose product is minus 8 and sum is minus 2. So we have to find all the factors satisfying product equal to minus 8. Then we have to add the two numbers. If you get a sum equal to middle term coefficient, so if you get x coefficient, then you will take that pair. So numbers minus 4 and 2 we are taking. So minus 4 into 2 giving minus 8. And if you add minus 4 plus 2, adding minus 4 plus 2, you are getting minus 2. So middle term we are splitting. What is middle term? Minus 2x. How I am writing minus 2x? Minus 2x equal to, so minus 4x plus 2x. Minus 4x plus 2x giving minus 2x. Now x square minus 2x minus 8. X square minus 4x plus 2x minus 8. We have written minus 2x as minus 4x plus 2x. Now grouping the terms and taking x common from first two. So x times x minus 4 plus 2 times x minus 4. So x minus 4 times x plus 2. Zeros of the polynomial x minus 4 times x plus 2 equal to 0, x minus 4 equal to 0, or x plus 2 equal to 0. So x minus 4 equal to 0, that is x equal to 4, or x equal to minus 2. Therefore the zeros are alpha equal to 4, beta equal to minus 2. Now in first question, second bit, find the zeros of the quadratic polynomial p of s equal to 4s square minus 4s plus 1 and verify the relationship between the zeros and the coefficients. So middle term splitting, p of s equal to 4s square minus 4s plus 1, multiply the coefficient of s square. Coefficient of s square is 4, constant is 1. So a into c equal to 4 into 1 equal to 4. We need two numbers whose product is 4 and the sum is minus 4. So minus 2 into minus 2. What we are getting? Minus 2 into minus 2, we are getting 4. If we add minus 2 and minus 2, we are getting minus 4. Minus 4 is coefficient of s. Middle term coefficient we are getting. So the middle term is split as minus 4s equal to minus 2s minus 2s. Now factorizing it, 4s square minus 4s plus 1 is equal to 4s square minus 2s plus 1. Grouping the terms, 2s times 2s minus 1 minus 1 times 2s minus 1. So 2s minus 1 times 2s minus 1. So 2s minus 1 whole square. What we are getting? So 4s square minus 4s plus 1 is equal to 2s minus 1 whole square. So 2s minus 1 whole square equal to 0. To find the zeros, we have to equate the given polynomial equal to 0. So we are equating it to 0. So 2s minus 1 whole square equal to 0 implies 2s minus 1 equal to 0 implies s is equal to 1 by 2. Hence the zeros are alpha equal to 1 by 2, beta also 1 by 2. Here we are having repeated 0 we are having. 1 by 2 is 0 of the given polynomial. Both zeros are equal here. Now we are verifying alpha plus beta equal to minus b by a. That we are verifying. So given polynomial taken, what is s square coefficient? 4. So a equal to 4. What is s coefficient? b. b is minus 4. What is the constant? c. c equal to 1. So a equal to 4, b equal to minus 4, c equal to 1. Sum of zeros, alpha plus beta. Already we got to the zeros. 1 by 2. Beta is also 1 by 2. Two zeros, 1 by 2 only. So repeated 0 we are having. So alpha plus beta, that is 1 by 2 plus 1 by 2, we are getting 1. So minus b by a, if you find minus of minus 4 by a, what we are getting? 1 only we are getting. So alpha plus beta 1, minus b by a also 1. That means alpha plus beta equal to minus b by a. So we verified it. Now product of zeros. Alpha beta equal to 1 by 2 times 1 by 2 equal to 1 by 4. Now we are finding C by A, 1 by 4. So alpha beta equal to C by A. Alpha plus beta is minus B by A. Alpha beta is C by A. So we verified the relationship. Now first question, third bit. Find the zeros of the quadratic polynomial 6x square minus 3 minus 7x and verify the relationship between the zeros and coefficients. So what we are observing from the given polynomial, here constant is given in the middle, x term is given in the last. So first we have to write the given polynomial. First we have to write this given polynomial in the standard form. So write in standard form. Given polynomial 6x square minus 3 minus 7x. So arrange in descending powers of x. 6x square, next minus 7x, minus 3. Descending powers of x we have written. So x square term, x power 1 term, next x power 0 term. So what are the coefficients of coefficients here? X square coefficient is a equal to 6, x coefficient is b, that is b equal to minus 7, constant is c equal to minus 3. So middle term splitting. What is middle term here? Minus 7x is middle term. Multiply a into c. A is x square coefficient. Constant is minus 3. So a into c is 6 times minus 3. 6 times minus 3 we are getting minus 18. What is the step 2? Find two numbers whose product is minus 18 and the sum is minus 7. Sum here minus 7. That is x coefficient. So middle term coefficient is minus 7. So which two numbers are satisfying? Minus 9 and 2. These two numbers are satisfying that. If you multiply minus 9 and 2, we are getting minus 18. And if you add minus 9 and 2, we are getting minus 7. So minus 9 plus 2 is minus 7. Minus 9 into 2 is minus 18. So split the middle term. How we split the middle term? Minus 9x plus 2x we will write in place of minus 7x. So minus 7x equal to minus 9x plus 2x. So 6x square minus 7x minus 3 equal to 6x square minus 9x plus 2x minus 3. Now group the terms. 6x square minus 9x. Here you can take common 3x. Take 3x common. So inside what you are having inside the bracket? 2x we are having minus 3. So 3x times 2x minus 3 plus 1 time 2x minus 3. So 2x minus 3 we can take common. Then you are getting 3x plus 1 times 2x minus 3. Finding the zeros, 3x plus 1 times 2x minus 3 equal to 0. Therefore, 3x plus 1 equal to 0 or 2x minus 3 equal to 0. So x equal to minus 1 by 3 or x equal to 3 by 2. Hence the zeros are alpha equal to minus 1 by 3, beta equal to 3 by 2. Beta equal to 3 by 2. Now we are verifying it. A equal to 6, B equal to minus 7, C equal to minus 3. These are the coefficients taken from the given polynomial. 6 is coefficient of x square, minus 7 is coefficient of x. Here C is constant. Sum of zeros, alpha plus beta. Alpha plus beta is equal to, we got alpha is minus 1 by 3, beta is 3 by 2. So alpha plus beta, we are adding these two, we are getting 7 by 6. After simplification, we are getting 7 by 6. Minus b by a, that is minus 7 by 6 we are getting. Minus 7 by 6 times here one more minus we are having in the formula. So minus times minus 7 by 6, that gives 7 by 6. So what we are observing now, alpha plus beta is 7 by 6, minus b by a also 7 by 6. That means alpha plus beta equal to minus b by a. We verified the relationship. Now product of zeros relationship we see. So product of zeros, alpha beta is equal to alpha is minus 1 by 3, beta is 3 by 2. So minus 1 by 3 times 3 by 2 is giving minus 1 by 2. So C by A, so minus 3 by 6 is equal to minus 1 by 2. Hence alpha plus beta equal to minus B by A, alpha beta equal to C by A, that is minus 1 by 2. So we verified the relationship. Now first question, fourth bit. Find the zeros of the quadratic polynomial 4u square plus 8u and verify the relationship between the zeros and the coefficients. So given polynomial 4u square plus 8u, take common factor 4u square plus 8u is equal to, if you take 4u common, what you are getting? If you take 4u common, 4u times u plus 2 you are getting. So to find the zeros, we have to equate it to 0. So 4u times u plus 2 equal to 0. Therefore 4u equal to 0, u plus 2 equal to 0. So u equal to 0, u equal to minus 2. Hence the zeros are alpha equal to 0, beta equal to minus 2. Now verifying. For the polynomial 4u square plus 8u, what is a? Coefficient of u square is a, that is 4. A equal to 4. What is coefficient of u? That is b. B equal to 8. B is coefficient of u. C is a constant. Here constant term. We are not having constant term, so we take constant term equal to 0. Sum of zeros, alpha plus beta. Alpha plus beta is equal to, alpha we got 0, beta we got minus 2. So 0 plus of minus 2, minus 2. Now we are finding minus b by a value. Minus b, that is minus 8 by a. A is 4. So minus 8 by 4. Minus 8 by 4 gives minus 2. So alpha plus beta is minus 2. Minus b by a also minus 2 we are getting. So we verified alpha plus beta equal to minus b by a. Now verifying product of zeros is equal to c by a. Alpha beta equal to c by a. So first we find the alpha beta value. Alpha into beta. Alpha is 0. 0 into beta. Beta is minus 2. 0 into minus 2 gives 0 only. So c by a. We are finding c by a. What is c? 0. A value is 4. So 0 by 4, 0. Hence alpha plus beta is minus b by a. Alpha beta is 0. So we verified relationship. Now question number 1, fifth bit. Find the zeros of the quadratic polynomial t square minus 15 and verify the relationship between the zeros and the coefficients. So we are writing t minus root 15 times t plus root 15 equal to 0. So a square minus b square formula I am using here. So a square minus b square is equal to a minus b into a plus b. So t minus root 15 into t plus root 15 equal to 0. Therefore t minus root 15 equal to 0 or t plus root 15 equal to 0. So t equal to root 15, t equal to minus root 15. Hence the zeros are alpha equal to root 15, beta equal to minus root 15. Now verifying, what is coefficient of t square? 1. What is the coefficient of t? 0. What is constant term? Minus 15. So a equal to 1, b equal to 0, c equal to minus 15. Now we are verifying the relationship between zeros and the coefficients. So alpha plus beta. Alpha plus beta is equal to root 15 plus of minus root 15 equal to 0. So minus b by a, that is minus 0 by 1. So minus 0 by 1 you are getting 0. We verified the relationship. Now sixth question. In the first question, sixth bit. Find the zeros of the quadratic polynomial 3x square minus x minus 4 equal to, okay, this is the given polynomial. 3x square minus x minus 4 is a given polynomial. We have to find the zeros and we have to verify the relationship. So taken given polynomial, writing the coefficients. What is a? 3. What is B? X coefficient minus 1. What is C? Constant minus 4. Now x square coefficient 3 and constant minus 4. We are multiplying these two. So A into C, we are getting 3 into minus 4 equal to minus 12. So we need two numbers now. We need two numbers. How those two numbers should be? If we add those two numbers, it should give x coefficient minus 1. It should give b minus 1. If we add those two terms, we should get minus 1. If you multiply those two numbers, we should get minus 12. So product is equal to minus 12 we should get. Sum is equal to this b we should get minus 1. So the required numbers are minus 4 and 3. If you multiply these two numbers, minus 4 into 3, you are getting minus 12. Minus 4 plus 3, we are getting minus 1. So we are taking minus 4 and 3. To split the middle term, we are taking these two numbers. So split the middle term. Middle term is minus x. So minus x we are writing as minus 4x plus 3x. Now we are writing in the given polynomial minus x. In place of minus x we are writing minus 4x plus 3x. So 3x square minus x, 3x square minus x minus 4. We are writing as 3x square minus 4x plus 3x minus 4. Now grouping the terms, 3x square minus 4x plus 3x minus 4. Now taking x common here. So take x common, x times 3x minus 4, here 3x minus 4 we are writing as it is. So 3x minus 4 times 3x minus 4, same thing we are getting, 3x minus 4 times 3x minus 4. So here we are missing this part. In the next slides I will show properly. Here verification of relationship. For the polynomial 3x square minus x minus 4, what is the coefficient of x square? 3. What is coefficient of x? Minus 1. What is constant? Minus 4. So alpha plus beta. What is alpha? 4 by 3. What is beta? Minus 1. So we are adding these two zeros, we are getting 1 by 3. So minus b by a also, we are getting minus of minus 1 by 3, that is equal to 1 by 3. So we verified it.